Hi, everybody. My name is David, and I work for Expedia. Do you listen me well? Yeah, sure. So I'm going to talk today about Akka streams and Spark streaming. I'm going to talk about what I did in my previous project at Expedia that was pipeline, anomaly detection pipeline. So I'm going to show you an example doing something similar, a simulation of what I did. So the technologies that I've used for this example are Scala, Docker, Apache Kafka, Spark cluster. Then we have Akka streams, Spark streaming, and a little bit of Spark MLlib. This is the architecture of the project that I created. So in the middle, we have an Apache Kafka broker. Then on the left, we have a producer that is every second is producing sales records, and then is putting them into a topic of Kafka. Then on the right, you can see the consumer of Apache Kafka that is grouping these sales records and creating features. So it's grouping these sales records in different windows, and then it's putting them into another topic. And then we have one Spark cluster that has one Spark streaming job running and consuming data from this broker and grouping the data and generating some statistics looking for anomalies. So first, start with the Akka producer. So this is a very simple service that every second is generating sales records. The sales records is quite simple domain, so it has a transaction timestamp, SOP ID, product ID, amount of records, and the total cost of these sales records. Then this is a bit more trickier, the consumer. So I define what is called a config. This config is defining how is the window, how we are going to group the data. So in this case, this config is grouping the data every 5 seconds and is splitting the data by SOP ID. And I define how the features they are created. So in this case, we have 3 features: the total amount of the total cost, the total amount, and the number of transactions. What about my experience with Akka streaming? So there is no windowing implemented in Akka streaming, so I had to implement my windowing. I used this block of this guy that was very useful. And then I really like graph DSL, so I created a very complex graph using broadcast and merge operators. And basically what is doing this consumer is just grouping in different windows, putting the sales records into features, and then putting them into a Kafka topic. This is how the pipeline flows. So we have the producer is creating sales records. We have, in this case, 3 shops with different product IDs. And then we have the consumer that is grouping them. In this case, we have 2 configurations, one that is grouping by SOP ID, another that is grouping by SOP ID and product ID. And it's kind of doing some grouping and aggregation. Then after these features they are putting into Kafka in a different topic, then the Spark streaming job is in this case consuming this data and is applying some MLlib. And we can obtain something simple, but we are obtaining here statistics like the mean, variance, standard deviation, so we can generate some anomaly detection from here. So from my experience, what I found that is good about Akka streams, so it's very flexible. For me, it was very fast learning curve, integrates really well with Akka environment, with Akka actors. It has implemented by default the back pressure. So what I mean with back pressure, if somebody doesn't know, is you have a very fast producer and you have, in the other way, a very slower consumer. So with back pressure, we solve this problem. Bad things about Akka streams. So by default, windowing and watermarking is not implemented, so you need to implement yourself. And it runs just in one node. It's not running in a cluster. About Spark streaming, what is good is that it's working in a Spark environment. So you have all the goodies of Spark. You have you can use Spark MLlib, Spark data frames, Spark RDDs, whatever you want, and then it has the windowing implemented. It has the watermarking implemented itself out of the box. And as well, if you want to include back pressure, you can set this property in the Spark context. What is not good, in my experience, is that it's not as flexible as Akka streams. If you want to do something more complex, then I recommend to use Akka streams and create your own graph. So here is the code if you want to download the code. And now we are going to execute this code. Yes. So it's quite simple. So if you want to execute this code, you just need to do svt clean docker, and we'll generate everything. I already did it, so we are going to just execute it. But before, we are going to take a look to the Docker Compose, how it looks like. So we have here defined the Spark master, 2 Spark workers. We have defined here the Kafka broker, the Akka producer, Akka consumer, and the Spark consumer here. So let's execute this. Now it's spinning up everything. Sorry. Here we have the producer producing every second sales records. Here is the consumer that, in this case, I have 2 configurations with 2 different windows, one window of 12 seconds, one window of 5 seconds, and is aggregating this and creating features and putting them back into Kafka. And then we have here the third guy that is consuming this data in a window of 80 seconds, in this case with a batch interval of 10 seconds, and is receiving the data, is grouping the data by ID, by a split ID, and is generating here some statistics that could help us in the future to apply some machine learning algorithm from MLlib. And yeah, that's all. Thank you.